So Google just dropped its new AI model, Gemini 3 Flash. And let me tell you, this isn't just about being faster or cheaper. This thing is challenging one of the biggest, oldest rules in the entire AI game. You know the deal, right? For as long as anyone can remember, the thinking has always been, if you want a smarter AI, you gotta pay for it. Not just in money, but in time. It's gonna be slower, it's gonna be more expensive. That was just the fundamental trade-off. Well, Gemini 3 Flash is basically here to say, think again. It's a model that seems to just break that rule. So today, we're going to dig into how it actually works, what this means for all the developers out there, and, what are the big catches, because there's always a catch. All right, so let's start with the big question. How is this supposedly lesser, lightweight model completely breaking all the rules? Okay, look at this chart. Honestly, when I first saw it, I thought it had to be a typo. This is a benchmark for autonomous coding. How well an AI can write code all by itself. On the left, that's Gemini 3 Pro, the big heavy hitter model. And on the right, that's Flash. And yeah, the smaller, faster, cheaper model is actually beating the Pro model. What? This one chart tells you right away that something really, really different is going on under the hood. So that leads to the million-dollar question. How in the world do they pull this off? Well, the answer isn't just one thing, but it all starts with the model's core architecture. The secret sauce here is something called a Sparse Mixture of Experts, or MOE for short. Now, instead of having one giant brain trying to do everything at once, which is super inefficient, MOE is more like having a team of specialists. There's a smart router at the front door that looks at whatever you ask it to do and says, okay, for this job, I need the coding expert and the language expert, but everyone else can just chill. It only activates the parts it needs. It's kind of like having a whole hospital full of doctors on standby. You don't need a brain surgeon, a cardiologist, and a dermatologist for a sprained ankle. You just need the right expert. A request comes in, the router picks the right team for the job, they get to work, and boom, you get a super efficient, accurate answer. And this is where it gets really cool. This approach enables what they call adaptive thinking. So for a really simple task, like, renaming a file, it uses just a tiny bit of its brain power. But for something really hard, like debugging 1,000 lines of messy code, it can spin up more of those experts, using more compute to make sure it nails the answer. It scales its effort to the problem. But it's not just the architecture that's impressive. Look at this number. 1 million tokens. That is the size of Flash's context window. That's how much information it can keep in its short-term memory at once. And that, my friends, puts it in the same league as the biggest, baddest, most expensive models out there. Yeah, 1 million tokens sounds like a big abstract number, so let's put that in perspective. What does that actually mean? It means it can read and understand about 1,500 pages of text, or 50,000 lines of code. Or, get this, it can process around 45 minutes of video, audio, and all in one go. That is a massive amount of context. Okay, so we've established it's smart, it's efficient, and it has a gigantic memory. But how do you actually, use it? How do you control all that power? Well, that brings us to the developer's toolkit. So the coolest new toy for developers is this parameter called thinking level. Think of it like a knob you can turn. You can set it to minimal for those super simple lightning fast tasks, or you can crank it all the way up to high when you need it to do some really deep multi-step thinking. And that medium setting, that's a sweet spot that's only available for Flash, giving you a perfect balance of speed, cost, and smarts. Now, this next part is super important for anyone who's actually going to build with this. To keep track of a complex conversation, the model sends back something called a thought signature. It's basically its little memory of what it just did. And developers now have to send that signature back with their next request. If you forget, the whole conversation just breaks. It's a bit stricter, for sure, but it's all about making the AI way more reliable in the long run. Okay, so you take the incredible speed, you add that massive context window, and you throw in this fine-grained control, and you realize it's all pointing to something much, much bigger. We're talking about a completely new way of thinking about building software. And this is it, Google Anti-Gravity. This is being billed as the first agent-first platform. What does that mean? It means it gives AI agents their own little office, basically. They get a code editor, a terminal to run stuff, and even a browser to go look things up. And the agent manager, that's like mission control. The human developer isn't writing every line of code anymore. They're more like a project manager, directing a whole team of AI agents who are all working together. So yeah, the goal here is nothing short of a total paradigm shift. We are trying to move from a world where humans painstakingly write every single line of code to one where they manage teams of autonomous AI agents that write the code for them. And a model like Gemini 3 Flash, fast, cheap, powerful, that's the engine that could actually make this whole thing work. But okay, let's pump the brakes a little. As amazing as all this sounds, this model is far from perfect, and it comes with some pretty huge trade-offs that you absolutely need to know about. All right, let's start with the good news first. Independent tests gave Flash something called an omniscience score of 55%. Now, that number measures how much stuff it actually knows and how accurate that knowledge is. And 55%? That is the highest score ever recorded for any model. So, point is, this thing knows a ton of stuff. But here's the catch, and it's a big one. That same analysis found that when Flash doesn't know something, it will just make up an answer 91% of the time. Let that sink in. This creates this crazy paradox where the model is simultaneously a genius and a compulsive liar. It's brilliant, but it's also dangerously confident when it's wrong. And developers in the community are definitely noticing this. The term I keep seeing pop up is that it's a one-shot monster, meaning its first answer to your question is often absolutely brilliant. But if you try to have a longer conversation with it, its performance can just fall off a cliff. It struggles to stay on track. So you might be asking, with those flaws, why would anyone use it? Well, this table pretty much answers that question. Just look at the cost. It is 4 times cheaper than the Pro model. 4 times. And then look at the speed. It's almost 3 times faster. For a ton of different applications, that combination of price and performance is it's a game changer. It's too good to pass up. So here's the bottom line. Despite its very real flaws, Gemini 3 Flash has completely shattered that old idea that smarter has to mean slower and more expensive. It has totally reset our expectations. It's created a brand new baseline for what we should expect from a top-tier, high-speed AI model. And that leaves us with one heck of a question, doesn't it? We've got a model that's faster, cheaper, and sometimes even smarter than the big guys, but it's also way more likely to just make stuff up. So is this the future of AI, making it accessible and scalable for everyone? Or have we just created a much more efficient and much more confident liar? That's the real puzzle with Gemini 3 Flash. And figuring out the answer is going to define where AI goes next.